What's up, class? We've got this disc to make here. It's got 6 holes on it, and I'm going to show you a new button on here called the hole feature. So let's dive right in. What you're going to make is this part right here. It's a simple disc, and it's got 6 holes on it, and they're all spaced evenly, and 2 of them are the same. So there's only 3 holes, but they're all kind of across each other, as you can see right here. This one right here and here, this is called a counter bore. Right here is called a countersink, and then this is just a regular hole. And the countersink, I gave a thread. And I'll show you how to do all of that. Step 1 is to make a disc that is 4 inches by 1.5. So make that real quick. Boom, just like that. All right, so let's go and create a sketch on the front. I'm going to click on the front view so I can look at it. What I want to put is a point. So look for this button, and it's the same on an iPad and on the on a computer. So I'm going to put a point right here. I'm going to take out a dimension tool, and I'm looking for here 2.5. That cut in half is 125, so 1.25. Now make sure that it's directly above it. That is real important. If you didn't get it directly above it, then make sure to use the vertical tool to help yourself out. You click on both points and then click vertical, and it will make sure that they're there. Now I want this to be repeated as a pattern. So we're looking for a tool called circular pattern. I'm going to click on circular pattern. I'm going to click on the point. It automatically assumes to spin around the middle. I don't want it to be 3 times, so I'm going to double click on that 3x and I'm going to put a 6, enter. And then it asks me to right click. I don't remember what it does on a tablet. I think it's a double click, maybe with 2 fingers. I forget. It will let you know. There we go. Okay, so we got it. So here is our 6 dots. And then I'm going to hit the OK button, check mark button. And I want to use the hole feature here. So I'm going to click hole. And if I look, we have a 1/4 of an inch through. Yours isn't going to come up looking like this. It should come up looking with the word simple. So simple was a 1/4 of an inch, 0.25. Oops. And make sure that it says through. And I'm going to click on 2 of these holes. And then I'm going to hit the check mark. Notice that the other points disappear, and that's kind of normal. So I'm going to come over here and I'm going to bring them back by clicking the Show Sketch To, the little eyeball button. You should be able to see that on an iPad. It brings up the eyeball. Just click it off. Now I'm going to click the hole button again, and I'm going to click these 2 here. And if I go back here, this one and this one, is it's got several numbers to it. Let me show you what you're looking at. This is called a counter bore. So a counter bore is, there are 2 types of screws. Let me see if I can bring these up on camera. Look at the heads of the screw. This one right here has like a cone shape, and this one sits flat. So the type of screws that sit flat, you can handle that as an inventor or an engineer in several ways. You can actually have it screw into the material and sit flat on the material, like this. Like this is a piece of metal. It sits flat on it. Or you can do something where the screw sits kind of embedded in the metal. The 2 ways to do that is with a counter bore or a countersink. A counter bore takes the head of the screw and sinks it below the material. So whatever metal or wood or something it sits below it. Why? So that your hands aren't rubbing against this. It's more aerodynamic. There's multiple reasons. You could also sink it down and make a shorter screw. Like a lot of toys, if you were to grab them, you would see like You see that hole right there? There's a hole here. Inside of there, there's a screw. It's sunk deeper in there so I can use a shorter screw if I have a shorter distance to travel. These screws right here, see this one right here, even though it's not a very big screw, it's short and it sits flush. I see how when I turn to the side, I can't see it anymore. You'll find a lot of your game controllers will have that. The Wii has a cover plate, but they have screws back here sunken in. The purpose of that is so that your hand isn't rubbing against it. It's more aerodynamic. It looks nicer. Um, Sometimes the ends of these screws will have little burrs from the way they're cut that can catch on clothing. So there's a ton of reasons why you would want the head of the screw to kind of be sunken in place instead of sticking out. So I've got a counter bore that I'm going to do here. It says that the hole is 0.375, that's 3/8 of an inch all the way through, but the counter bore itself is 1/4 of an inch and or 3/4 of an inch, and it's 1/4 of an inch deep. We want to change this from simple to counter bore. The hole was 0.375. The width of cross was 0.75. That's across the top, and then the depth of that is 1/4. See how there's 2 cylinder cuts here? It's so that the head of the bolt can sit flush and kind of be above the below the surface. All right, we have one more hole to do, and this one is going to be a countersink. I have this this little hinge here, and if you look, where's my camera? You see how it kind of has like 2 circles? It's got a little cone shape, and that cone shape is to match the cone shape of the screw so that it sits on the surface, like I've said before. See how the screw sits in there? You'll see that for a lot of wood screws will have what's called a countersink. I don't know if it has anything to do with like a sink on a counter in a kitchen. I don't think so. Sink meaning you sink the head of the screw into the material. Counter, I'm not sure why counter, but that's just the way it's called. So the countersink is just that cone shape. That cone is right here and here. It says 0.375 through, and then it says 0.75, and then degrees 82. So let me go to countersink. We got 0.375. This top part is supposed to be 0.75 for the top of the head of the bolt. And then this said 82 degrees. And we want it to be here and here. Now, another thing that it says is 20 UNC-1B. I don't remember what the -1B is. It has something to do with the class of threading. And UNC has to do with like an international standard for threads, like threads on a screw, like we did with a bolt thing. So the 20 UNC means 20 threads per inch. So we're going to use that little helix command. Where is it? Here it is, helix. So I'm going to click on that, and I want it to be 20 revolutions. It's 20 revolutions per inch, but we have 1.5 inches, so it's going to be about 30, just to make it look kind of close. There we go. And we'll do the same thing over here. Because it's 1.5 inches, and it's going to make 20 threads per inch. Now, we don't need to cut those. I cut it on one, and the look of it wasn't much different. So this helix gives it that threaded look without taking more time from you and without taking up too much file space. So that look is just fine. So this is the completion of the project. It's got all of this stuff filled out now. We've got our holes, all 6 of them, with all their exact numbers to match. And you're going to go ahead and you can take a screenshot of this. Make sure that you have the name up here at the top in the picture, and that I can see the tree. Or you can send me a link. I don't care, whichever one you want. So either one of those will work. If you have any questions, make sure to ask. Hope that you learned something new today about how screws and stuff are called out. Bye.